Good morning, everybody. Sorry, it took me a second to get my screen shared there. I'd just like to, thank everyone for the opportunity to present this morning. And today I'm going to be talking about Retrotec's rCloud application, which is a mobile application that's used for doing air tightness testing on, residential and commercial housing and air tightness tests on duct systems. As I mentioned, my name is Ben Walker, co-CEO. I've been co-CEO of Retrotec for the past 3.5 years after the founder, Colin Genge, after 30 plus years in the industry, eventually retired. My prior role with the company was technical director, so I was in charge of developing all the software and doing all the product development for digital pressure gauges and all the other blurador air tightness testing equipment that we sell today. As I mentioned, I'm going to talk about rCloud. I'm just going to walk us through actually doing an air tightness test with the mobile application and kind of talk about the key benefits of cloud storage with the data that's collected and opportunities for geolocation and things like that to gather weather data, and also talk a little bit about remote logging with our digital pressure gauges, where now you can enable the remote logging and log the pressure data directly to Microsoft Azure. So as I mentioned, rCloud is a mobile application that you can run on your mobile phone, tablet, or Surface laptop. When you conduct an air tightness test, it's important that you actually know that the user, the person, is actually at the location conducting the test. So we leverage the GPS chipset in the mobile devices to capture the latitude and longitude of the user, and then use that data to ensure that they're on site. And then we also use it to collect the information about the house that they're testing, like the square footage of the house, the current weather at the house when they conducted the test. Is it's super windy conditions and stuff that could affect the results. And then we also collect the data from the gauge and the fan, which you'll see in a minute, directly from the gauge to the device, so that all the raw pressure readings, everything, all that information is captured and then uploaded to the cloud. Yeah, so in case you're not familiar with what a blurador looks like, it's a cloth panel that's installed in the doorway to create an airtight seal. There's the digital pressure gauge connected to the top part of the frame, which is connected with hoses to the fan that's used to either depressurize or pressurize the house to, typically 50 pascals. And then the amount of flow that's going through the fan then is what's being pulled in through leaks throughout the house. And then the mobile application is connected to the digital pressure gauge via Wi-Fi. And here's just a picture of this this rental house that's on site where our manufacturing facility is located. So this is the house that actually conducted the test at just last week, just to prepare the slides for this presentation, just to give you a sense of what the house looks like. Here is the actual rCloud application running on the mobile platform. So as I mentioned, you can do either a blurador test to do an air tightness test on the whole house, or do an air tightness test on the duct system or exhaust fans. And then we have several of the standards around the world, really, for each of them have their own kind of criteria for conducting the test. So we have like step-by-step for the user for each one of these. So for this test, we did the ResNet 380 test, which is for North America. You also have the option of doing either just a single point or a multi-point test on the house, just depending on the requirements for the standard and and the kind of accuracy that you're looking for, like a single point not being quite as good as perhaps the multi-point test. The next screen shows that we're going to depressurize the building. We're located inside the building. The test fan is located in the front door. And for Washington State, then the ACH 50 requirement is 5 air changes per hour or less in order for it to meet current energy code. And as you can see, the mobile application is geolocated us on the map, so as our latitude and longitude. So it's a little bit tougher to maybe falsify or fake the results of, sometimes people would have tested one house, gotten a passing result, and then use the same values for testing other houses. So this kind of prevents that from happening. It also used the GPS location to capture a little bit of information about the house through Zillow in North America. And as you can see here, it's 1,200 square feet and approximate volume of about 12,000 cubic feet. It also captured the current weather conditions, which at the time there was no wind, nice calm day, 21 degrees Celsius. And after you go through those checkpoints, you've collected all the information about the building. Now the actual test will be performed. It connects to the gauge and the fan. We go ahead and start the test. Now it's depressurize the house to 60 pascals and taken a measurement of 1,900 cubic feet per minute. It also captured a bias pressure for the current wind conditions. And after the test is performed, then it has a summary of all the results, which actually this test failed because since it was a little bit nice outside, some people had some windows open in their offices. So, and then at the end, then you get a report that you can use to share the data with your local authority or colleagues or the homeowner of the house. And then all this information is then summarized and stored in the cloud. And to date, there's been 25,000 tests using rCloud, the air tightness application. Yellow indicates air tightness test using the blurador, and the green air tightness test using for duct systems. And so, the goal really was that previously the software that people used for doing this kind of testing was all the information kind of stored locally on their own machines and everything, so that you couldn't really leverage the information. So we thought that taking advantage of Microsoft Azure and storing the information centrally in the cloud then would provide us an opportunity down the road to analyze the information and do some trend analysis on like building stock, and you could maybe see like which areas are doing better than others for contractors and things like that. And then also a new feature in all of our pressure gauges is that you can connect them either Wi-Fi or via Ethernet to the internet, and then do your own real-time logging to Microsoft Azure as well. So you could then analyze the pressure readings in real time from another remote location. You could leave the gauge on site somewhere and then go to another location and view the data and set up alerts if a certain pressure was reached or not, and then download the data, the raw data, as a CSV file. And that concludes my presentation for today on the rCloud mobile application. I'm going to head and pass the floor to Anouk.